Hey everyone, we're going to take a look at using a SimpleDeform system to control an object, maybe a tree or a crop or whatever that we want to have locked on the ground and sway. So as we play this, what's going to happen, it's going to get some force, play and bounce back, and nice and easy. What's interesting here is that we're using a low-res VDB mesh based on the high-res in order to get a nice cage that behaves well. And then we can use a SimpleDeform that's going to give us vertex, surface, and volume particles. We put those under the force bound because we're going to apply then we store those positions at birth, and then we create a force that's going to give them a kick and a push. And we lock the bottom verts into place so they don't move. And then we're going to handle returning these original guys to their positions. And then we're going to transfer and use a ShapeDeform to affect an object high particle using the force bound particles. Alright, so let's take a look at how we might create this. Let's get started. Here is a fresh scene, and we've got these objects in here to kind of give us an idea how big things are. This yellow sphere is 1,000 units, blue sphere is 100 units diameter, 10, and red is 1 unit diameter. So our corn here, let's go ahead and get on the measuring layer and do a little measuring. Yeah, it's about there. So let's measure from, say, bottom to top, and we get about 270 units, roughly. We just want to know that number so that we can control and say, hey, from zero here on the ground, you see the ground line, up to the height, how much of it's going to get affected by that force. So let's go ahead and create a TP. We'll do that under particle systems, thinking, let's drop one out here. Okay, and so the first thing we're going to do is we're going to create a system group. And inside that system group, we're going to create two groups. One of them is going to be object low, and the other one, of course, is going to be object high. And the reason we're going to do this is because we're going to have a low-res object cage that's going to affect the high-res object. We'll make this kind of a reddish color, and then the high, let's go ahead and make it more of a purplish, bright purple color. Okay, then we also know we're going to need some force-bound particles. We'll call this force-bound to organize those. And inside there, we're going to have, we'll call this vertices, and we'll call this, I think it's surface, and finally volume. Okay, and so let's go ahead and just give these some colors so that it's easy to see. Let's see. Let's do some greenish color for the verts and some blue for the surface, and for the volume, let's go ahead and make them some purple-ish. Fine. Okay, so whenever you're dealing with systems in TP, we'll just call this SimpleDeform system. I like to create a system name, and then within that system name, create a cashdyne set so that we can begin and organize all of our stuff. So the first thing we're going to want to do, and I just created a whole bunch out of habit, but we can modify those as we go. We're going to create something where we're going to set up kind of the initial parameters of what we've got. And so let's say we're going to have an import, or maybe an original birth. Okay, and so for that, actually in our scene, let's take a look. Let's hide these utility stuff and take a look at the corn simple that we've got. This is just this basic model that I made. You can see all the objects in here and the elements, blah, 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 how they're not attached, right? And so there's going to be no mesh continuity. And that's why we're going to want to use VDB, turn this high res into a VDB, and then that way we can sim the VDB, because the VDB is going to be a continuous mesh, and then we can turn around and say, hey, low-res VDB mesh, go ahead and affect this high-res mesh, and it'll get some nice behavior out of it. So that's what we're going to do. So for starters, we're just going to unscripted tutorials, let's go ahead and pick that corn simple and say, hey, you're going to be my object low, and start as an instance shape, right? And so let's triple check our settings here. Now, we've kind of got some old school habits that we do where we start on 1001. Our shot range starts at 1000. 1001 is where the sim's going to start. You'll find that all the Hollywood movies start at 1001 generally. And let's go ahead and hide our scene geo. And what we're looking at now is a TP particle. Okay, so we've imported it into this object particle. We're using this corn simple mesh. We say, hey, use your shape, and there it is. Great. Okay, so next what we're going to do is we're going to actually, very important, remember this is the object low. This is going to be our low res cage. Right now it's using the high res mesh, but we're going to change that when we turn this into a VDB. Let's go ahead and do that next, just because it's a linear train of thought. So what we're going to do is let's stay organized and call this VDB. So VDB, what you need to do is come to the VDB category. We need to create an open VDB container that is going to allow us to define what grids we want to have available here. And right now we're just going to go ahead and use distance. And so what we'll do then is, let's use these menus, because using the menus here on the right is a nice way to be able to see all the different operators available under this category. So SDF, sign distance field, we want to go ahead and do a shape to volume. And what this basically means is we want to take a particle shape and turn it into a volume or a grid, a VDB grid. So the open VDB we're going to be dealing with is that open VDB we made. And you can see under this list there's only one right now. As you get a whole bunch of different ones going and interchanging data, you're probably going to want to go ahead and rename these. Let's call this low mesh or something here. Okay, so now we've got shape to volume. We can say, hey, it's already updated that. Notice it's that. Okay, so the volume P group that we're going to store this data in is just going to be the object low. Okay, and what we're going to do, this means, hey, who is going to have this grid? Who's going to own this grid? Who is this VDB grid going to be attached to? And which grid are we talking about? You actually get to be able to create 3 different grids with this shape to volume grid operator. You've got the distance field grid. You can create a reference of that, basically a copy. You can create a volume fog and a velocity grid. So you basically get 3 different grids that you can create with this one operator. And which particle group is going to have those grids, meaning each particle who belongs to this group you pick, each particle gets his own unique grid. Okay, basically his own volume data. Okay, so we're going to create a distance grid for this guy, and for now we're going to go ahead and just say update single. Okay, this means that it's only going to create this grid data once. We don't want it to create over time. You use subsampler automatic if the mesh is changing, if it's morphing or moving around. Not moving, but morphing. Okay, so the volume size, in this case, let's just go ahead and use 1. And let's bump it up to 5, see what we get. We remember that it's always a good idea to know the world units that you've got around here. Remember that 10 units is this big, 1 unit's that big. So your grid, the voxel cell, if it's 1, it's only going to be this big per voxel. And that might be a little overkill. So always err on the side of making stuff really rough first and then modify later as you go, to make it more high res. So basically, spend as little computation power in the beginning as possible. All right, so we're going to go a voxel size of 5. Let's go ahead and first let's use a show VDB to display what data we're generating. Now the show VDB needs to know, hey, which VDB main container am I dealing with that defines the grids that are available. That's going to be the low mesh that we made, the only one right now. Which P group are we dealing with? Which group particles do we want to see grid data for? Well, that's going to be object low. Remember, we're generating that on these guys here. And then our grid that we want to see, well, of course, there's only one grid right now, but of course you can have tons of different grids if you need to. And what do we want to do? Right now it's going to show us the bounding box. So let's step back and step forward, and hey, look at that. Lo and behold, we get some data. Let's get these views organized. Oh, we got 2 TPs. That's a problem. Make sure we don't have. Let's get rid of that TP2. We don't need that. Of course, my keyboard shortcuts don't want to work right now. That's fun. Okay, there we go. So 1 TP, great. I get this weird problem where my keyboard shortcuts interfere with, or my viewport settings interfere with the keyboard shortcuts. All right, so we see the bounding box. Let's turn off let's hide this volume display. This is some nifty new display methods that work in Max 2023, which are great, but we're going to skip that for now. Here's our bounding box. Let's go ahead and turn on exterior and see what we get. Okay, we see some dots in here. You see those little blue dots? Well, let's go ahead and turn this down. Hey, we see a whole bunch more. So this is telling us there's VDB data that's being generated. And really what the shape to volume does is it takes the faces that are part of that particle shape, and within that voxel, per voxel in this space, it's going to create volume data where the faces exist. Okay, so right now it's looking really rough, and our reduced voxels is 0, so that we're showing every voxel. That's telling us, hey, your mesh is really low res, because remember we picked that voxel size at 5. Okay, well that's all fun and fine, but let's go ahead and look at an actual mesh that it creates. What we need for that is going to be the volume to shape. That's going to take a volume and turn it back into a mesh shape. Now the open VDB container that we need to deal with is that low mesh that defines all the grids available. The volume P group, who we have, is the object low. The distance field is our distance. Okay, and all the rest of this stuff we're not really using. We don't need the reference mesh right now. We've got there's no velocity going on this guy. And these parameters here are going to like relax disoriented faces. We can also do things like transfer from the original mesh shape. We can get the face normals, UVW, material ID, smoothing group info, or we can even snap the mesh to the surface of it. But we don't really need those right now. And what happens is we can, as we back up and go forward, see that our mesh is absolute garbage, right? It's just super low res. Well, that's because our resolution is too big. Let's come down. Okay. Let's get dangerous. Let's turn edit on the fly off so that we get real-time updates. Step forward again. And now we can see our tree gets a little bit thinner. Let's turn off show VDB, and let's just go ahead and decrease our voxels until we start to see stuff. Okay, so get down to 1. You can see that what it's doing is it's creating these little cubes, right? So we're getting closer, but we need to get lower voxel size. Let's try 0.2. Okay, hey, there we go. Getting some stuff. Still a little rough here on the ends, right? We could go 0.1, and that's going to generate a really dense mesh, which is going to be not fun to deal with. Okay. Okay, so we want to generate a mesh that we can use that's not super high res, that it is super fast to calculate. And so what we're going to do is, before we turn that back into a mesh, we're going to do a one-time step that converts that into or we're going to modify that grid. Okay, now here, let's do this. I'm going to show you a quick little trick for creating a one-time switch that is super handy, because we're going to say, hey, I need a true value to fire just once, and it's going to have a 0 duration, so it's going to be immediate. And what we're going to do is this is going to come out, and we're going to say, hey, when the reached comes out true, I want to do something. The reason we do this bool egg timer is so that no matter where our sim occurs in time, no matter when TP starts in time, we just run this once. We don't have to worry about anything with like time interval, don't have to go back and modify those values. Just go ahead and fire once. And what we're going to do with that is we're going to come back into the operators, VDB, and this time we're going to go to the grid category, because what we're going to do is we're going to get the grid for this. Okay, so we need to say, hey, which OpenVDB domain we're going to be dealing with, which P group is going to be object low, and what do we want to do? What we want to do is we want to kind of inflate and dilate that VDB grid. So let's start with this one first. Actually, because it's an SDF, let's use the SDF version. And that's going to be the resize VDB. So the resize VDB allows us to dilate, erode, open, close a distance field. So we're going to connect that to here. This means, hey, it's going to look at this OpenVDB domain, take this particle groups grid, take this distance grid, and it's going to resize it. Now, it's going to resize it and it creates a result, but that doesn't really do anything. You actually have to set that back on the grid itself. So we're going to use set grid here. And we have to tell it, hey, who are we dealing with? And what are we going to transfer? We're going to transfer an instance. Okay, so the distance comes here like this. Now, let's go ahead and check here. Let's set this back to 0.5 voxels so it's not super huge. Let's make sure our volume to shape is down below in the process tree so that it fires last within this branch. Okay, and so now what we get is this nice big fat smooth grid. But you can see that as we step forward, it keeps getting fatter. It's like too many potato chips over time. So this is where the bool egg timer comes in handy. We're going to use a reached, and we're going to feed that into the on of the get grid VDB. What that does is that says, hey, only get the VDB grid once, and fires once on the first frame, and as we step forward in time here, it just stays at that first because it only ever fired once. Okay, so now we've got a really nice, fairly low-res mesh that we've created. Yahoo! Okay, so this is going to take care of our initial setup here. We're going to come back to this and add the high-res stuff later to transfer that data, but this will work for now. This is a really good time for us to save this file. So let's do a save, and let's just call this start 01. Okay, so the next dynamic set we're going to make here is going to be called action, and inside action we'll move these other ones. And let's go ahead and turn it on the fly off for the moment so it's not constantly calculating. And in the first step of action, what we want to do is we want to create the particles who are going to exist on the verts and faces and within the volume of this new shape here. And to do that, we're going to come into, I believe it's generator. No, I'm totally wrong. Is it SimpleDeform? Haha, let's go find. Hey, shape. Okay, so operator, shape, SimpleDeform. TP's got so many operators now, it's like, where does this thing exist? But fortunately, remember, you can always press tab and you can just type in SimpleDeform if you can type. So SimpleDeform is going to say, hey, who are we going to deform? We're going to deform the object low. You're going to create some vertex particles, which are going to be jointed, meaning they're going to kind of maintain their distance and length from each other. And we're going to create that into the vertices group. Let's go ahead and step forward and just see what we get here. This vertex group, let's set these guys, well, let's check our, so right now it's set to global, right? Global and show mesh. Let's go to the master dynamic. Hey, what's our viewport global set as ticks? Okay, let's see what we get. Step forward, and now you can see, yep, indeed, well, you can kind of see all these little green ticks on this thing. Yeah, there they are. All right, so now we're going to also go ahead and create the surface particles, and we'll create a random amount. Let's just create 2,000 for now. Let's go ahead and create some volume particles as the volume particles. The raster, let's try 2. And actually, if we disable these 2 and step back and forward, let's see what, I don't see many there. Let's turn object lows mesh off. And now he's still set to global, so he's still going to use the global settings. If we set this to now maybe like ticks, what are we seeing there? We're seeing the, oh, well, we're forcing the mesh on, so that's why. Okay, so there's our volume particles. Let's get a little better volume. Let's reduce that raster so that we get more granularity or more particles to deal with that create a better representation of the volume itself. Okay, Yahoo! Now auto break we're not going to deal with because we don't really want this thing tearing apart. If you do want your meshes to tear apart, turn this on, and then you'll have to start adjusting the thresholds until you see, hey, as these vertices move, jumping around, as the vertices move and split apart, it'll tear the faces up and the pieces will detach, and you can put them into a separate detach group so that they do their own thing. You can also transfer mesh data from the original mesh onto those, I believe it's onto these other particles, in order to store information about their mapping channels. And you could say, hey, take map channel 1 data, put it in a certain data channel. So make sure you set up your data channels. Oops, oh, that's an interesting bug there. Look at that. And you could create data channels to store that in. Let's get rid of all these extra groups that decided to jump into place. Let's see, are we still live here? Good. Okay, so there's that. Now what we're going to do is, speaking of data channels, we're going to, remember we want this, well, you know what? Let's just go ahead and create a force, because you want to follow the logic of how do I get this stuff to do what I want it to do. You can see we could use some black boxes that make life a lot easier, like, hey, just create that bool egg timer right away. Or you can go ahead and come into VDB, copy it, or you could just, hey, save it out right now to a black box, which would be great. The more black boxes you have, the easier your life's going to be, well, as long as they're organized and not too crazy. But we could say, hey, all force bound at birth, get a kick. Let's create a kick in a certain direction and create a force that's going to push them into, say, well, where are we in space here? Let's get organized and look from the front view. Well, there's X. Okay, let's kick them out on X positive. Well, let's try 500, see what we get. This could be a direct force. Okay, so boom. Yeah, well, hooray, guess what? Yeah, it's kicking them all at the same speed, right? And they all just move like that. Let's add some variation just to see the difference. And yeah, creates the variation. Okay. Let's turn the mesh back on and see what we get. Oh, I don't see much, do you? Okay, it's because force this setting is still turned on. Okay, and so if the show mesh is not checked, we're not going to see the mesh. That's a little bit crazy about TP is you have to watch your management of the display settings, the mesh dynamic. A lot of times it's nice to turn that force this setting off so that you can control each particle group independently. So now what we see is, what do we see? We see our volume particles flying off to the right, and we see our object low particle just kind of sitting there. Okay, that's because SimpleDeform works by it can create these volume particles, but they're not really going to affect the mesh. If you want to affect the mesh, you got to use the vertex particle. So let's back up, turn that on, and if you want more accuracy, you create this surface particles. So let's do that. Okay, now what do we get? Well, we get this whole madness mess going on here because we've got variation in the force, but you do see now at least the mesh is getting moved and deformed. Things don't always look awesome right away, but it just takes a little work. Okay, so now the variation, with no variation, they're all getting pushed, but they all just move. We want to lock those bottom verts down, right? So let's take a look. Where are we? We're in the front view, so our mouse is going to show us here in the status bar where our Z is. So let's say from, what Z is like minus 1.5 up till 10. We want those to stay locked in place. The easiest kind of hack way to do this is to give them a whole bunch of friction. So let's say, we'll call this lock. We're going to say, hey, who do we want to affect? Let's affect, well, we could affect the verts, or we could just affect all the force bound. Let's say we need to find out if you connect, basically we want all the force bound who are within that Z range, right? From -2 or whatever, -5 up till 10. So we need to get all of those. What's the easiest way to do that? We say, hey, take all the particles, and you take a particle into a 0.3 vector. What that does is says, hey, get my particle position. By default, it's reading the particle position. Then we need a threshold to say, hey, take the Z value and get everything inside, say -10 and 10, and I want to affect them. I want to do something. I want to give them some friction. So I say these particles are going to get that friction. This threshold's only going to allow the particles who are within this range to be sent or affected by this operator. And the friction, we're going to go ahead and set this to something big, like 1,000. Okay, so now as we play, what do we get? Well, yeah, we get, look how, get a nice hard streak cutting those off. But at least those bottom ones are staying in place and they're not going anywhere. That's great. Okay, and so one of the things that we need to do is we need to control this force a little more. We only want the force to really kind of affect the upper area of this corn. So as you might imagine, we're going to use the Z position of this to control how much force is being applied. Okay, so let's do this. Let's say, hey, again, get my position and I get my Z. In this case, we're going to use a value to value because what we want to do is we want to say, hey, as my Z goes from, in this case, looking at our status bar down here when we move our mouse, as our Z goes from, say, roughly 270 down to, say, 130 or 100, so 270 to 100, I want this force multiplier to basically go from 1 down to 0. Okay, so as I go from, and now look at our graph here is set up, so remember the input is the x-axis, so this axis here along the bottom. So we're going to say, just for clearer English, so to speak, we'll go from 270 to 100. So we're going to say 270 to 100. And really what we want is we want at 270, which is the beginning here on X, and over here is 100. We want the force to be really strong, and we want it to fade down to 0. Okay, so now let's go ahead and throw a multiplier in here, float set to mult, and we'll just use that to say, hey, this is going to be my strength. So right now, originally the force strength was 500. set this to 0 just so that you know that it's coming from somewhere else, because this input is coming into strength. It means it's going to override this strength value. It means it won't affect it. This number won't affect it at all. It's all coming from this. So let's say 500 here. Okay, so now you can see that as we play, we get a stronger force on the top and not so much on the bottom. Okay, all good and fine. Remember, we're trying to create something that sways in the wind, and part of the sway is that it's going to need to try to come back to its original position. So we're going to want to go ahead and save first, and then we're going to want to go ahead and create a data channel for like the original position of something, so that when these particles are born, they remember, hey, where was I when I was born, so I can resume that original position. We'll create a 0.3, just call this oripose. Yes, there's a space in there. TP, you don't have to worry about string data too much. If you're going to be exporting or dealing with other programs, you might have to worry about it, but let's just do it this way. Okay, so we could set up something. We need to store this data channel, right, for the original position. We could do something where we feed all these out into the data position or into a data channel, but that's a whole bunch of work. Why don't we use the power of group hierarchy to say, hey, all force-bound particles at birth, store a data channel on that particle. Remember, we're saying, hey, at birth, the out only controls when this happens. It's only going to happen at birth. And what we want to do is we want to store a 0.3. Now, remember, 0.3 vector, you can just connect this right to the particle. You could go ahead and use position, right? But you don't have to. You could just use particle. Just remember that's a shortcut there. Just make sure you don't get confused later. And yeah, there's other instances where that becomes a little wild. Like if you tried to let's see here, connect the particle into an integer. That's going to store the PID, right? Because every particle can resolve to a number itself, an integer. But just remember, yeah, if you feed a particle output into a 0.3 vector, it's going to capture the position. So now they remember their original position. Okay, so we're going to call this store org post. What? No, oripose. Okay, so now the next thing is we need to say, hey, actually come back to your original position. Okay, return to posts. Okay, in this case, we're going to go ahead and tell all these force-bound particles, and we're going to use their stored data channel. We're going to use a dynamics called position follow, and we're going to say, hey, these guys, position follow. Now right now we're going to let's go ahead and set it to constant speed, see what we get, right? Oops, what did I do there? Okay, well, almost nothing happens. That's always fun. Let's try a bigger force to give them more of a kick. Remember, this is our force. Oh, God, I totally forgot to tell you, but one of the great new things in TP, I know it seems minuscule, but it's actually really cool, is you can set the color of the operators to a custom color. And that makes life visibly much easier to see things. So keep that in mind. You can also, if you select multiple and you click outside those operators, remember, not on the operators, but outside, you can set multiple colors at once. So that's nice. Anyway, let's kick this up to like 2000, so it's 4 times more force. And okay, well, we got a little something there, boink, but not much. So let's change our position follow return. Let's say, hey, speed of 1, 50 times less power. What's going to happen? Boom. Our corn gets kicked way over. Get some stretch activity there. And then I'm going to come back. That's too long. Let's try maybe 10 times more. Okay, so boom, and then you can see it's coming back here. Nice. Let's take that force up a notch. Let's go to, say, 10,000, so it's 5 times more. Okay, boom. Okay, probably too much, huh? Yeah, let's come down a notch. Okay. So, yeah, you can see that the motion here is a little bit slow, right? And so we're going to want to adjust that so it behaves a little bit nicer. The first thing to try, of course, is just to change some of these values here and say, hey, what if it's 5% laziness instead of a constant speed, right? Okay, well, that's not enough. So, boom. Okay, well, we can get that. Yeah, it's starting to do it. You know, maybe that'll suffice for what you're trying to do. Remember that our frames are going fairly, well, not real time here. So do a preview to see what you're actually what your behavior is going to look like. Okay, so yeah, that's going to get kicked out. Yeah, you know, this is probably easier. I was doing something in another file where we could actually, here, I'll show you, where we can store the z height at birth and use that as a vertical multiplier. And then, so that things that are low at 0 get a value of 0, and things up high get a value of 1. And then that return force could be gradated so that, you know, the laziness down at the bottom happens really fast, and as it gets higher up, that laziness gets more loose, so to speak. Let's do that just so you can see how that works. Okay, so we're going to need, this is our data channel 0. Oops, not 09. Let's go 0, which is my position. And then we're going to create another data channel. And you notice that I create all my data channels up here on the system operator, because that way when I wrap this up as a black box and put it somewhere or drop it in another scene file, all those data channels are going to be pulled along and easily accessible from that top location. Okay, well, what we need to do to get the 0 to top height, again, of course, is to get the z value. I'm going to gradate it. Again, we're going to go, let's do 270 to 0. Actually, let's do 0 to 270 since it's already 0 down here and 1 up high. So remember on the input of the x-axis, where this is 0, this is the start of this. And at 270 is on the far right, and at 270 that value is way up high, and that value going out, which is the y-axis, is going to be 1. And over here at 0, that output value is going to be 0. So we're going to store that in a new data channel, and let's go ahead and put that into a float, right? So that data channel we didn't make yet, but we can call it, call it height multiplier or whatever. Okay, and so remember to set this data channel to 1 so that the data is going to be actually stored there and not overwrite your other data. Always check these guys. Remember to set your settings where stuff's going. Okay. So that gets stored there. Now we can go ahead and in the return to position we can say, hey, use my height multiplier, and we'll say, hey, as my height multiplier goes from 0 to 1, remember, which is the values that we're looking at here, it's going to output 0 to 1 based on 0 to 270. My height multiplier from 0 to 1, I'm going to control the laziness. Now, let's say as I go from 0 to 1, I want that laziness to be 0. Well, not up to 1, because 100% laziness, you do that and you'll see what happens, right? It actually, the laziness essentially is really lazy. It's not coming back. So let's change that. Let's make that like 0.8, which was a good value. Okay. And so boom, get some nice gradation up there. That's fine. You can mess with the curve to play with how exactly how it's going to affect as it goes up. But That is the beauty of control. And speaking of control, I wanted to interject here and say that, the nice thing about TP is that it gives you the ability to create these systems by using very low-level components. And then you can take that system that you've built and you can save it as a black box or preset, and you can use it anywhere for anything that is applicable. Using presets that are made for you, obviously, you can often do things quickly and work within their parameters, but that's just it. You're stuck within their parameters, and you can't really, dig deeper or change it very easily. So, kind of depends how you like to go. That's why I like TPs. It's very customizable, and you can build things to operate how you like. Okay, enough blabber. Let's get on with the show. What are we going to do next? Well, we're going to take the, remember we're dealing here with a low-res mesh. We want to affect a high-res mesh. So let's go back and save. And this time we're going to go ahead and create a new dyne set under setup. Let's just call it make high. And in make high, really what we want to do is say, hey, the object low, and let's talk about this for a moment. We're going to generate a new particle, so we'll use position born. We want object low to create a particle, just one, called object high, whose lifespan is going to be infinite, so to speak. There's no speed, no direction variation, leave the rest of it the same. Now we could use this particle age to say, hey, only do this at birth, but actually position born kind of does this by default, so you don't really need that particle age, so that's nice. But what we do need to do is we need to pass along a bunch of data to the new particle that says, well, actually let's right click and say show all. We need to do things like get the size of our particle, get the shape of our particle, get the alignment of our particle. So and actually let's rename this, call this object high. So object low is going to create an object high, and this object high is going to get a bunch of particle data from its creator. That's going to allow it to exist in the same spot. And you can't really see much there. Let's go to wireframe. Somewhere there, do we see one? No. Let's try this. What's happening? Our object high is still set to global, right? So you're not going to see it in there. So let's change that and set it to ticks. Okay. And so you can see that he's over here. Now, what's happened? Why is he not in the exact same space, right? Okay. Well, looks like maybe his rotation's a little bit off, or, well, we've got his alignment there. What else could it be? Well, let's try scale and see if we can pull that. Remember, the scale, and you can look at these inputs, each one has kind of scale written twice, and the second one has a parentheses around, or parentheses around the word scale, and that telling us the data type. And so when we connect that to just a generic particle, it's going to grab the scale data from that particle. Okay, so still no dice on that. That's still a little bit offset. Now, what could that be? Is that our... Let's move this up. Let's turn off our other rules so that we're not calculating anything else in that process. Okay, and so boom, as we do that, what we see is our object low and object higher in the exact same space. So something else we were doing was affecting that. Okay, so let's turn open VDB back on and see that, yes, that is wrapping around our mesh perfectly. All right, you can see that in there inside, pink and purple. Okay, and so now as we turn on action, what happens is, boom, there's that offset because I'm guessing it's going to be the force, because the force is going to be displacing that thing. Yep. And so that's kind of the nice thing about being able to turn off dyne sets for these rules and not have too much wiring going on in one area, is that you can actually limit what happens and kind of see where things might be going wrong. Okay, Yahoo. Let's get on with the high-res ShapeDeform. So in this case now we're going to create call it ShapeDeform. ShapeDeform is going to rely on a shape operator, not SimpleDeform. That's the one we use to create the extra particles that are going to deform our original shape, but we're going to use the ShapeDeform operator itself. Okay, so who's going to get affected? Okay, the target is going to be, of course, object high. Who's going to be affecting object high? Yeah, that's going to be the force-bound particles, not object low, right? Well, let's try it and see what you get. Okay, yeah, well, he's moving around, but not seeing him carry it there. Let's go to force-bound. Oh yeah, there's also the type options. We'll take a look at those. First, let's just play this to see that, hey, even the force bound is not going to, include subgroups would help. Okay, so now you start to see some movement there. But actually what we really want is we want the nearest link. Detection radius basically turns each particle kind of into a skin bone. And so now you can see that there's actually no the purple high res is always following, and so it's really wrapped up in that thing, up in the by the force-bound particles. Let's test it again just so you can see this, and this is why you want to experiment and get an understanding of what works and what doesn't. Okay, so our low-res mesh is actually moving. But he's not going to be affecting. Our low-res mesh is actually just one particle, and he is not moving itself. His the object low particle is stationary, but his mesh is actually moving. So the only way we can capture that mesh data is by using the force-bound. That way we'll get those force-bound particles movement and apply it to the high-res mesh. Okay. All right. So, yada yada, on and on. Yeah. So that's really, and it might seem a little bit complex, right? There's quite a few steps to get something like this. You might be like, well, I can just drop in a few operators and something else and get the same result. And it's like, well, yeah, you could, but doing it with TP gives you the ability to add that extra customization. You can really control what's happening on a per particle level because you have these force bound, these SimpleDeform particles. You can use these to affect this high-res mesh. And remember that using the VDB to create kind of the low-res cage is very useful. Let's turn a bunch of this stuff off again so we can see that. Actually, without the VDB, we've got this mesh, which is really just elements who are kind of slapped together in the same mesh. But with the VDB, it's going to give us actual interconnected continuous mesh. And so that works really well with the SimpleDeform vertices, or vertex particle joint, for deforming other particles. All right, so that's a very long-winded discussion about how this works. Remember, you can now save out. You can save out this black box. That's why you would go up here to, well, you would have to create a new dynamic set, drop it in here. And now you've got this SimpleDeform system. You can right-click and just say save, and you can figure out where you want that to go. and then you could save all the particle groups with it, as well as the data channels, so everything remains intact. And then boom, drop it into a new scene, or you could just take the TP and you could do a save selected here in Max, and save the TP itself out, drop that into a scene, and keep all that TP data that you then just reconnect your imports, figure out what you want to input. And of course you could use the layer to particle instead of object to particle, so that you could be a little more procedural and just grab stuff off a certain layer. That's all fine in this case, where object to particle works plenty easily. Okay, folks, well, I know that's kind of a little bit of a long-winded roundabout discussion, but hopefully it kind of touched on quite a few things that'll give you a hand in understanding how you might use both a low-res VDB cage combined with SimpleDeform in order to apply animation to a high-res mesh using the ShapeDeform. So remember, SimpleDeform to create extra particles who modify a particle's shape in mesh, and then the ShapeDeform, where you can say who you want to modify, whose mesh you want to modify using which particles. And it's better to have more particles in the operands in order to add resolution to affect that target particle mesh. All right, well, if you have any questions, shoot me an email. Or actually, better yet, come over to the Discord forum for Seba's channel, because if you want real-time feedback and prompt answers, that is the best place. Also, the Facebook group's good, so we'll see you around, folks. Have a good one.